Welcome to the demonstration of Deep Stellar, a quantitative analysis framework for recurrent neural network. In this video, we demonstrate three key features of Deep Stellar: abstract model construction, coverage-guided testing, and adversarial sample detection. Let's begin with the first part. Now we demonstrate how to use Deep Stellar to extract DTMC model for an RNN, and we take an ASR model as example. We also prepare some sample audios and set the K and M configuration. And here we go. This is the generated abstract model. We also provide visualization interfaces to visualize the abstract state transition model. You can find the states and transitions labeled with transit probabilities, and also to visualize the state vector trace for a given sample like this. The trace is like a trajectory over the state space of an RNN. In the second part, we demonstrate how to use Deep Stellar for the coverage-guided testing. To apply it on the speech domain, we prepare the deep speech model and some sample audios as initial seeds. The sample seeds are mostly with accurate transcripts, and we check the average word error rate. It is about 0.02. Now let's start the testing and use state coverage as the testing guidance. Let's listen to some generated samples.
From the railway station in the distance came the sound of trains, ringing and rumbling.
Did you invite him to the concert?
The speech remains clear and easy to recognize after mutation. Now we check the word error rate of the newly generated samples. We can see the word error rate increased to 0.12. We can see the retained samples can help to increase the coverage and possibly lead to bad transcriptions. Deep Stellar can also work on NLP applications. We tested a sentiment analysis RNN model trained with IMDb dataset. This time we used transition coverage to guide the testing, and prepared some movie reviews as initial seeds. Let's start the testing. We can see the increasing adversarial samples and transition coverage. Now we check the quality of the mutated adversarial samples compared with the original seed. The adversarial samples generated are basically with minor perturbations that won't affect the original meaning of the sentence. For the last part, we show how Deep Stellar can distinguish benign and adversarial samples, and we demonstrate with the deep speech model and with a pre-trained classifier. Now we listen to two audio clips.
Can I help you?
Now we check it on deep speech and let Deep Stellar to examine. Deep speech gives roughly accurate transcript. Now listen to the next one.
Can I help you?
Let's check again the transcript from deep speech. What? Make a credit card payment. It seems deep speech is attacked by this audio. Let's check whether Deep Stellar can identify which audio is benign and which is adversarial. Wow! Good job, Deep Stellar. Now we visualize the traces of these two audios with the interfaces we show in the first part. The two audios sound almost the same but trigger obvious different traces. And Deep Stellar is able to capture such imperceptible difference and identify the adversarial ones. Thank you for watching.